Hi, everybody. So today we are going to be looking at unit conversions two ways. Now, depending on whether you're in sixth grade, seventh grade, or eighth grade, I may have taught you this differently. If you've been with me since sixth grade and now you're in eighth grade, then you've probably seen both these ways, similarly with seventh. But I am going to start out with a very basic way of using the acronym King Henry's daughter usually drinks chocolate milk. Now, this acronym is going to be used as kind of an understanding spatially of where each of our prefixes that we would want to convert to are. Now, in chemistry 6 right now, we're only going to be responsible for K, which stands for kilo, U, which stands for our base unit. So this would be like your liters, your meters, seconds, moles, grams, anything like that. That would be in the center, no prefix added. Centi is another one that you'll be responsible for. Centi, like centimeters, centi, and then milli would be the last one. So M-I-L-L-I, milli is going to be your teeniest, tiniest there. Now, overall, two things that I want you to think about when we're doing unit conversions. Number one, am I converting in a way that makes sense? I don't want you to just blindly convert your units and think about, oh, well, I'm going to here and the number is going to be bigger. And what I want you to ask yourself there in that moment is, does that make sense? Does it make sense that the number for kilometers is going to be bigger than your number was when it was in meters? Think about that critically. The answer should be no, that wouldn't make sense because kilometers, there's 1,000 meters for 1 kilometer. So would it make sense that your number for kilometers was bigger if kilometers kind of encompasses more meters? Probably not. So that's the first thing. The second thing is that if I want you to think about you and your own personal learning style. If this acronym does not work for you, then stay tuned for the second way that we're going to talk about. Right now, like I said, this is just for your purposes and to understand just spatially where everything is. And I like to teach this in sixth grade because it's a little bit easily digestible, more easily digestible than using unit multipliers, but we'll get to that soon. So let's do a couple of examples here. So let's say that I have 0.5 meters, and now I want to convert that to centimeters. Now, what I'm going to do here is I'm going to see that meters is a base unit. Meters is going to be here at the U, meters. But I want to put a C onto this meters. I want it to become centimeters. So what that means is that I need to move my decimal place over 1, 2 spaces to the right. So I'm going to take my decimal place. Hold on, let me change my color here so that you can watch me do this. I'm going to take my decimal and move it over 1, 2 spaces. And now in this space where there is currently an M, I'm going to get rid of that and go back. Sorry, this is my first time using the writing pad in a very long time. So I went 1, 2, and now in that space where there was an M and there is now nothing, I'm going to fill in a 0. I'm filling in the 0 in blue because it was not there originally. Now that decimal place moved over and is now here. So what was 50 meters is now 50, or sorry, what was 0.5 meters is now 50 centimeters. So that would be unit conversion number 1. Let's try another one. Hopefully I'll have my technology situation figured out. So if I wanted to now go and do some converting from, I'm going to erase all this. let's go from 300 kilometers to meters. And now one thing that I want to point out to us right now, I know that meters is abbreviated with a lowercase m, and milli is also abbreviated with a lowercase m. So that can be very confusing to us sometimes. Now, milli is never going to be written out all by itself. We're never just going to convert this to milli. It would have to be attached to something. Millimeters, milliliters, millimoles, for example. It could never just be convert to milli, because that doesn't really tell us what we have. So please note that even though milli, the prefix, is abbreviated with a lowercase m, that if it's all by itself, it's actually meters. I know that that's very confusing, and that's why later on you'll see why we use uppercase and lowercase letters for different things. But for right now, let's just start off with this. So similarly to what we just did with our last unit conversion, we took our decimal place and we moved it over in a certain direction. Now in this, there is no decimal place. 300, there's no decimal place there. So we're just going to assume that it's right at the end of the number there. And we're going to move our decimal place from kilo, 1, 2, 3 little hops over in this direction to the right, from the prefix of kilo to the base unit of meters. So what that looks like when I do it is if I have 300 point, I move over 1, 2, 3 spaces, this is where my decimal lines up, and then I fill in the zeros. So I would go from 300 kilometers to 300,000 meters. Hopefully this is making a little bit more sense now. Let's try one more, and then we will move on to the second way that you can convert units here. I want to erase my screen though. So let's use something that's not meters this time, because I realize I've used meters twice. Let's go from 927 milligrams, and I would like to convert that to grams. So my prefix milli, like I said, is going to be at the M, and I am going to now need to go backwards. I'm going to need to go towards the left, because milli is over here, and my U, my base unit, that's where grams lives, is right over here in the middle. So I'm going to need to hop over 1, 2, 3 spaces to the left. Again, just like in the last number, we're going to assume that our decimal place is right at the very end here, and we're going to go over 1, 2, 3 spaces, and the decimal will actually wind up in front of the 9. Now here is something that is very, 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 very important to me. I always would like for you to write a 0 in front of the decimal point. If you don't, I call it a naked decimal, and I am not a fan of naked decimals. I think they need a little 0 there. I would like a leading 0, and I would also like a trailing 0. If you've been in my class, you know that sometimes a trailing 0 is not always there, but I'll tell you if it is, or I'll make it very, very apparent. That's a conversation for another day though. This leading 0 is super important because hypothetically, what if I were working in the lab and I just wrote really quickly 927 grams? Do you know that there's a decimal in front of that number? Can you really see this little guy right here? Barely. So if you were just looking at that super quickly and you did not see that there was a decimal there, then you could perhaps think that instead of 0.927 grams of reagent, you needed 927 grams of reagent. And if you needed 927 grams, or sorry, if you needed 0.927 grams, but you used 927 grams, you're going to have a lot of waste. We do not like to waste things. So for that reason, I always say put a zero, a leading zero in front of your decimal. I know that it's kind of annoying, but as we get into the habit of it, I think it's very important, especially because I want you guys to all be very good in the lab. Now, let's do another, but let's think about the second way of converting units. Oh, I got rid of my M by accident. Okay. So when we are doing unit conversions the second way, we can use unit multipliers. Now, unit multipliers would basically just tell us what 10 to the power of, what exponent we would need to be multiplying by or negating to multiply by to get our value. So again, just using these three that I have laid out here, kilo is going to be 10 to the third larger than our base unit. Centi is going to be 10 to the negative second, and milli is going to be 10 to the negative third. It's really hard to use a writing pad when you're a lefty. Oh my God. Okay, I'm sorry that that is the most atrocious three in the whole wide world. So when we are going inward, so if we are multiplying inward towards the base unit, you are going to use multiplier as is. I don't know why my writing has suddenly become terrible. Let me show you an example of what that would look like by using the multiplier as is. So what I mean by that is that if I had 10, oh my goodness, 10 kiloliters, let's say, and I would like to convert to liters. Jeez. Oh, hi, Farrah. My cat is screaming if you couldn't hear her. Then I would just multiply 10 times 10. What the heck is happening here? 10 to the third. And if you wanted to convert that into scientific notation, then you absolutely could. Technically, your number should be between 1 and like 9.99, but I'm also perfectly fine with you leaving it like this. And then if you were going to go the opposite way, if you were going to go outwards from the base unit, what you would need to do is negate that exponent. So you would need to flip the sign of the exponent. So an example of that would be if you were going from, let's say that you had 40 moles. What the heck is happening? I don't know why this has decided to stop working, but I promise you, it usually does. 40 moles, and you wanted to convert that to millimole. Then what you would need to do is 40 times 10 to the third. Like I said, you would flip this sign. So ordinarily it would be negative third, but since you're going outward, you would need to flip it to be positive third. Now, again, if you're in the 7th or 8th grade, this is more applicable to you. If you're in the 6th grade, you can absolutely just use the King Henry's daughter usually drinks chocolate milk, or King Henry doesn't usually drink chocolate milk. Now I'm going to go figure out why my writing pad is being so annoying and not working. But thank you for watching. Hope that this helps. Have a great rest of your day.